In this video, we're going to be looking at an actual commercial rooftop package unit inspection. The reason for this inspection was that the customer felt that they had taken a voltage surge, a high voltage surge to the equipment, and that's why it wasn't working. Other people disagreed. So as a third party, I was called in to find out exactly what was wrong with the equipment. So we take a first look at the package unit. The first thing we do is basically make notes of any damage on the outside of the unit. Okay, so we're missing a condenser panel here. The disconnect is showing some signs of rust. There's screws laying on top of the disconnect. The top of it's not in bad shape. There's no major dents or bruises. The fans are not operational, and there's rust on the sides of the motors, which just shows age. It's not anything new and unusual. Look at the condenser coil. We want to look at all sides of the coil. From the outside, we do see some wind and debris related damage. This sits next to an airport, so that's really not surprising. It's pretty wide open. And the unit's a 2003, if I remember right. Look at the other side of the condenser coil. Really nothing unusual there. Start taking a look at the rest of the unit. We want to take a look at the economizer, which is this area right here. Economizer, if you remember, is the part that actually pulls fresh air into a building. And we look at the economizer, and that is totally shut. In fact, on the outline of the picture here, you can see that someone actually taped it shut, so it wasn't operational anymore. Walking further around the unit, we see the condensate drain line is broken. Believe it or not, every single drain line on this roof was broken off in much the same manner. Don't know why. So that's 3/4 inch PVC that needs to be replaced, or at least the elbow needs to be replaced. Again, looking closer at the unit, there's nothing major here. We look at the data plate because there's some things we're after. I want the run amps, I want the LRA for the compressors, I want the condenser fan motor amps, and I want the blower door amps. I did cut off the model and serial number here just for some privacy for the people that own this unit. Okay, so again, further look around just gives us a better idea of what's going on. Pull the unit open the compressor cover. This is what I see. Okay, so I have it's a 2-circuit system, so I have a Y1 and a Y2 with 2 compressors. Pretty rusted out. Again, age and relationship to salt water of this equipment. Really, it's not unexpected what I'm seeing here. Okay, note this big ball of wire here, because we're going to get back to that. The big ball of wire is all the control voltage for the pressure controls. Okay, wiring cover's on. Pull the wiring cover. Well, look at the side of it first. You'll note that Y1 and Y2 are jumped out. Again, this is important. Okay, come down here, take a closer look at the compressors just to make sure the wiring matches. We get the model and serial numbers off the compressors. Again, there's my great big old ball of control wire. Again, this is going to be important as we continue our conversation. Take a look at the capacitors. I do all my electrical checks first. Okay, you'll notice that the contactors, if this was a preventative maintenance, I would be recommending both of these contactors be replaced. There's starting to be burning marks here. Again, nothing that signifies voltage surge, and the fact that there's still some factory default anti-tamper here tells me that this contactor hasn't been replaced yet. Don't see any burnt wire, see a lot of rust. Come over here, take a look at the contactor on the left. Okay, this is my indoor blower motor contactor. Okay, it is severely burnt, and again, this is wear and tear related. This is not voltage surge. You'll notice that there's 2 wires. There's no wires on the left-hand terminals of this contactor. Unfortunately, I didn't get a picture of that angle. but there's no wires over there. So this contactor is actually not operational at this time. So again, we're going to get back to that. Okay. And actually, sorry, that is the C1. That's compressor 1 in the circuit. So we come over here, take a look at the blower relay, which is hiding out in the back here. Nothing magical there. Everything's connected, including Y1 and Y2 on the terminal strip. W2 is disconnected, but that's been jumped someplace else at the unit. Okay, take a look at the transformer. Everything's wired correctly. I took some voltage readings real quick because before I stuck my fingers in anything else, I wanted to make sure the unit was not powered, and I don't trust disconnects a lot of times. So we ended up with 5.96 across the top of the first contactor, 7.73, that's just stray voltage on the top of the other contactor. When it verified my disconnect was off, opened the disconnect cover, and again verified the disconnect was off. I also wanted to see the condition of the wires in here. I'm looking for anything that could signify high voltage surge or burn marks. Burn marks are a dead giveaway if there's been an electrical problem. Melted wires are as well. Now, before I go on to do any resistance readings, especially on compressors, I do always self-check my meter. Put the two leads together, make sure I'm getting some either 0 or as close to 0 as possible on ohms. It makes a difference. Start ohming compressor terminals. Verified that the other end is completely disconnected from everything on the contactors. It was. I chose to disconnect it at the contactor rather than here because the compressor terminals are screw-on terminals. 0.9, 0.7, 0.9. This is a three-phase compressor. They should all be relatively close. I'm fine with that. Repeated the same for the second compressor. So we knew our compressor windings were good. Now the other thing that I always check is every single terminal to ground. Okay, and I'm looking for OL. I don't want any terminals to have any current path to ground. Okay, that signifies that a compressor might be grounded out. Went on to check my capacitors. Okay, the capacitors, there's two of them because there's two condenser fans. They're rated at 10 microfarads. One checked out at 9.84, the other checked out at 10.32. And again, take pictures of it all to make sure it's all valid. Now it's the first time, so that's my electrical with one exception, and the one exception is the indoor fan or the blower. We'll get to that. So while I'm in the compressor cabinet, I decided that since we're looking for an electrical failure, I wanted to do a quick acid check. Okay, I used the quick checks. Basically what it is, it's a little cylinder with some reactive paper inside. You blow refrigerant through it, okay, and it actually turns pink if there's acid in the refrigeration oil. So once again, did both of them. Both came back negative on acid. We have two compressor circuits, had to do two at the same time. And again, two compressor circuits, two at the same time, both came back negative. Let it sit a while, still negative. Put my gauges on the first circuit. Okay, that's compressor 1. Okay, now you'll remember compressor 1 and compressor 2, or Y1 and Y2, were jumped out. Okay, so compressor 1 has 0 psi of refrigerant in it. Okay, no refrigerant in that circuit whatsoever. Compressor 2, okay, we now have normal standing pressure for our temperatures, 134 psi, which tells me the condenser and evaporator is around 76 degrees. You know, can't argue with it. The inside building temperature and the outside, not in the sun, was about that. So I'm fine with that. It may end up being a little bit undercharged, but there's more problems here than that. Went around to the filter side. Okay, now here's where I'm starting to look for a leak. Okay, I have 0 psi in a refrigerant circuit. I really need to find out where it is. Okay, I didn't carry a tank of nitrogen onto the roof, so I wanted to pull the filters and check the evaporator. You'll notice the sides of this evaporator coil are in pretty bad shape. This is a restaurant, there's grease around. Okay, so you'll notice the evaporator coils have a lot of grease buildup on the outside. In a restaurant where there's grease buildup, there's usually salt, and this is an aluminum evaporator coil. Okay, looking closer, it's tough to see in the picture, but I was able to find the leak right here. That tube in there is actually corroded away. So that's where my refrigerant in the first compressor went to. However, this still doesn't explain to me why the compressor burnt out. Okay, remember there's low pressure switches all the way through here. So it doesn't explain to me why the compressor burnt out. Okay, and again, there's more corrosion and stuff over on this side. This evaporator coil is toast. Needs to be replaced there and there. Okay, went around and opened up the blower compartment. Okay, one of the first things in the blower compartment I noticed was disconnected high limit switches. Okay, it's usually not a good idea to ever disconnect a limit switch from a circuit that has electric heat. So followed it back, found the disconnected circuit, started taking a look at the blower motor. Okay, one of the complaints was that they tried to start this unit up and got smoke in the ductwork. Okay, and shut it right down. So I'm noticing that we have really badly rusted and dry bearings here. Okay, so we'll go further. Okay, see a lot of belt debris around this motor. Okay, this whole motor area has belt debris. Well, believe it or not, if a belt is getting that hot, a lot of times and throwing that much stuff around, especially if the blower motor or the blower wheel bearings are gone bad, this will actually appear as smoke in the ductwork because that smoke will be blowing around. Took a closer look, I found a belt that was starting to go bad. There's, believe it or not, another bad belt laying in the air handler. Okay, see a lot of debris around, lots of rust. Okay, notice the sag in this belt here. Okay, this belt is very, very loose on here. It's really not a correct tension at all. Okay, you should be able to push in ½ an inch, okay, on a belt for tension. This belt is really, really loose. It's probably not driving much of anything. It's probably sitting here spinning and smoking. Okay, now back to earlier in the presentation, I had talked about I had a ball of wire here. Okay, I did find out why the compressor failed. Okay, let's get back to my ball of wire. Right there. Okay, I did find out why the compressor failed. I pulled this wiring apart and I traced our pressure switches. Okay, ideally that low pressure switch on the refrigeration circuit would have taken the compressor out of the circuit and actually opened and made sure that that compressor was protected and was not going to run dry. What I found out was that the low pressure switch was actually bypassed and no longer in the circuit. So when that compressor lost charge and Y1 and Y2 were jumped out on the control board, okay, that compressor continued to run. From our conversations before, we know that refrigerant is part of what cools the compressor. So what I found here, and it's up to others to totally make the conclusions, but what I found here was I found out a bypassed high limit switch or a bypassed low pressure switch left the compressor running dry basically with no refrigerant to cool it. There was a leak in the evaporator coil which was caused by improper maintenance, and the smoke that people smelled was the fan motor belt burning up because it also was not properly maintained. So this is the type of things that you do find in package unit inspections, and it takes a while to go through once you find something. Okay, my whole goal is to find what is the problem. Okay, what caused the actual problem? So hope you got something out of that. And this is forensic HVAC, and it's actually quite interesting to do on occasion.